Okay, much better.
That's why you
All right,
said-
we're back, guys. All right. We're still in pre-calc. Okay, we're going to go over some solving equations. So I have, this is example number 38, and I have arctan of 2x minus 5 equals negative 1. Okay, if this is inverse tangent, to get rid of the inverse, what do you think I do? Flip them, or I could take tangent of both sides, right? This is like my theta, this is what my answer equals. I'm going to rewrite this as tangent of negative 1 equals 2x minus 5. Okay? If I'm solving for x, this is going to seem very, I don't think we did any like this in pre-calc. This seems very foreign, especially to me since I just taught this lesson, or this chapter. Okay, so tangent negative 1 is some weird decimal. That's not on unit circle. Oh wait, yes it is.
Yeah, it is.
No, it's not. I'm
No.
thinking where? I'm thinking inverse tangent.
Mhm.
Tangent of negative 1, there's no negative 1 angle. Theta does not equal negative 1. It equals pi halves, right? So I'm going to leave it tangent negative 1. So I'm going to say I'm solving for x. I'm going to add 5 to both sides. So I have 2x equals tangent of negative 1 plus 5. X equals tangent of negative 1 plus 5 all over 2. That's the answer.
But what's the point of doing that?
Well, just plug in your calculator and that's the actual.
Yes. I mean, we could estimate it to 3 decimal places. Same with like a radical, right? We would leave it in radical form because that's the exact answer. This is the exact solution to this. Okay, if I do example number 39, this has arc sine of square root 2x equals arc cosine of square root x.
Is the x under the parentheses? Or under the square?
Yes, it's underneath the square root. Okay. So here's where it might be helpful to, I can't just flip it, right? Because I have inverse sine of something equals inverse cosine of something. To get rid of the inverse, I take the original function of it. The same way I would square a square root.
You just sine both sides and cosine both sides.
So let's take the sine of both sides. And then sine and arc sine cancel. So I have square root of 2x equals sine of arc cosine square root x.
No, we can't cosine that side because it's.
No. So now we're at, we have to evaluate inside with a triangle. Okay? So I'm going to evaluate inside with a triangle. Arc cosine, this I can think of as square root x over 1. It's variable, so which quadrant do I put it in?
Adjacent of that one.
Which quadrant?
Okay, first.
First, because it's got variables. So, and it's adjacent over hypotenuse, so this is square root x, this is 1. We need to use Pythagorean theorem, so a squared plus b squared equals c squared, or square root x squared plus b squared equals 1 squared. X plus b squared equals 1, or b squared equals 1 minus x. So b equals the square root of 1 minus x. Does that make sense? Okay, so this side is square root 1 minus x. Now, this whole triangle is what's inside the parentheses. Now I have to take sine of the triangle. And that's going to be,
Square root of 1 minus x over 1.
right, square root 1 minus x over 1, or square root 1 minus x. And that equals square root 2x. Okay, now this doesn't look as bad.
square root, or
square both sides. 2x equals 1 minus x. Add that x over, so I have 3x equals 1, and x equals 1/3. As a reminder, if I square both sides,
Plus or minus.
Check it.
I have to check it,
This does
Oh.
not work.
okay?
Wait, why?
Like in case you get.
Because you could get extraneous answers. In this case,
What is
extraneous meaning they're not correct, that they
Oh.
don't work.
Okay.
Okay, so if I come back to my original where I had arc sine of square root 2x, well, okay, let's check this. If I plug in a 3, well, that's square root 2 over 3. That's not on the unit circle. We're not going to do that in here. Okay, or you can use your calculator to check. There's only one answer. It is the correct answer. Okay, but traditionally, if you square both sides, you
But if you
have to
get
check.
like 3 answers, you should
Yes,
probably check them.
you should probably check them. Okay, so x equals 1/3 is our final answer.
Is there a way, without the calculator, to solve arc sine of square root of 6?
No. No. Arc sine of square root 6 is just that. The only thing you could do with it to simplify it is approximate it to 3 decimal places with a calculator. That's the only thing different. Okay, any questions on the stuff we just did? This is the pre-cal. Okay, and there's going to be homework that's using inverse trig, so you'll have some practice, just like in pre-cal. Well, let's go into the calculus part. Okay, we good? Can I move on? Okay. All right. Derivatives of inverse trig functions. And just FYI, traditionally in the past, the AP exam covered inverse trig, pre-cal level inverse trig, without derivatives, without integrals. They do not do that anymore. So there's only calculus-related inverse trig on the test. And we do have, if you look at your formula sheet, there are derivatives for all 6 inverse trig functions. They look nasty. They're not as bad as they look. Okay?
It looks pretty bad.
What's the hardest part about them is memorizing them. Okay? On the quiz that we have on this on Thursday, I will have this on the quiz. I'm not going to hold you responsible for them yet because they're nasty. Okay? I probably should make you responsible for them, but we'll ramp up. I'll give them to you. All right? Okay, let me show you. So the first one, I can derive all of them, but I think rather than deriving them all, I'm going to just derive one of them, and you can see where they come from, because they come from the triangle. Okay? So d dx of arc sine of u is equal to u prime all over square root of 1 minus u squared. Okay? And if I were to say, so this is kind of off, this is our equation, but let me derive this, how this came about. So if I were to say sine x equals u, if I said arc sine u equals x, I could rewrite that as sine x equals u. Actually, let me change it to a y, just for, let's change this to a y, because then we'll find y prime, and that makes more sense to you guys. Okay, so this is like my theta, right? Well, sine y equals u, if I were to do implicit differentiation, derivative of the left-hand side is what? Cosine y
Times dy dx.
dy dx equals, this other side, I'm going to say u prime. Okay? Dy dx is equal to u prime all over cosine y. All right, cosine y if I were to draw a triangle, and I'm told arc sine of u, that's u over 1. That means if this is u, opposite, not u, sorry, opposite is going to be u, my hypotenuse is 1, this is going to be square root of 1 minus u squared using using Pythagorean theorem. So I could replace dy dx equals u prime cosine of u, or cosine of y, I mean, this is y, is adjacent over hypotenuse, or square root 1 minus u squared over 1, square root 1 minus u squared. Okay,
Yeah,
so
just deriving all
this,
of it?
I've just derived this.
Oh, so we shouldn't,
You can write it down for your enjoyment.
I'd rather just watch.
Okay. I'm not holding you responsible for this, but just so you see where it comes from. Okay? I can derive all 6 of them. I'm not going to. Let's just give you the equations. So let's go ahead and write, if we want to put them in our notes, we can do that. So I'm just going to rewrite this one again. d dx, I just said I'm going to write it neatly, and I just screwed up. New sheet.
Dude, a new sheet for a one little screw?
d dx of arc sine of u is equal to u prime all over square root 1 minus u squared. d dx of arc cosine u is equal to negative u prime all over square root 1 minus u squared. So that's kind of nice already. They're the same, except the cosine, which is good because derivative of cosine is always negative, right? So here we have the negative. d dx of arc tangent of u is equal to u prime all over 1 plus u squared.
So it's the same as the first book that was square root.
Right.
Is that because, like, cosine over sine,
Tangent is sine over cosine.
or, yeah, sine over cosine?
But it doesn't say why the negative is gone. And I'm sure that that's where it does come from, but I'm not going to derive that right now. I'd rather do some example derivatives.
But, derivative of arc sine u over arc cosine u.
Is secant squared.
Yeah, but it's not the same thing as arc tangent, though.
Right, yeah. No, it's not. Okay, let's keep going. Arc d dx of arc cosecant x, u, sorry, is equal to negative u prime all over absolute value of u times u squared minus 1, square root of u squared minus 1. Here we're getting nasty. Okay? d dx arc secant of u is equal to u prime all over absolute value of u square root u squared minus 1. Again, these are the same. The one that's negative is the one that begins with a c, just like with straight up derivatives.
So cosecant derivative is negative.
Yes.
Okay. I feel that.
Okay. d dx of cotangent u is also negative. Because remember, all the derivatives of trig functions, if the trig function begins with a c, the derivative is negative. So this is negative u prime all over 1 plus u squared.
Oh.
So there is some nice stuff in here if we lay them out like this, where so these are the same, cosine is negative. These are the same, cosecant's negative. These are the same, cotangent's negative. So if you can memorize 3 of them, you're good to go, as long as you remember that the c's are the ones that are negative. Does that make sense? Okay, let's apply this with some examples. Let's do some calculus.
Is that arc?
Which one?
Is that arc when you're making this with?
Oh, you're right. This is arc cotangent u. Yes, thank you. Okay. Let's look at example number 44. And this says f of t is equal to arc sine of t squared. And we're asked to find the derivative, find f prime of t. Okay? What is my u going to be? T squared. Du dt.
Wait, are we finding, we're finding derivative, right?
Yes, I'm going to, instead of du dt, I'm going to say u prime. U prime is 2t. Okay? I'm just going to lay this out at first to help us plug into our equation. So so I know f prime of t is going to be equal to u prime all over square root of 1 minus u squared. Right? Well, my u prime, I just said, is 2t all over the square root of 1 minus u squared, which is t to the 4th. Does that make sense?
Mm-hmm.
So this is my final answer. Okay. Example number 48. F of x is equal to arctangent of square root x. What's my u? X to the 1/2. U prime, 1/2 x to the negative 1/2. Yep. Okay, so f prime of x, the derivative of arctangent from our equation is u prime all over 1 plus u squared. You have a question, Michaela?
I was just a little confused when I figured that out. Because it would be minus 2 over 2, right? Oh yeah, never mind.
Okay. So here I've got my u prime all over 1 plus u squared. My u prime, we said, is 1/2 x to the negative 1/2 all over 1 plus u squared. Well, u is x to the 1/2. That's square root x. If I square that, what do I have?
You square, oh, you add them.
You multiply them.
Okay,
So this is x to the 1/2 squared.
oh, you square the whole thing.
Yes. So this is 1/2 x to the negative 1/2 all over 1 plus x. But I can still clean this up. I can put the x to the 1/2 on the bottom, and I can put the 2 on the bottom. Okay, so this is going to be 1 all over 2 square root x, parenthesis 1 plus x. Okay? Does that make sense? So some of this, the hardest part's going to be the algebra, other than memorizing the equations. Which shouldn't shock us, because that's just the way in general it is. Okay.
Algebra is sometimes the hardest part.
Yes. You good? Okay. Okay. Now let's look at number 50. Number 50, h of x is equal to x squared arctan of 5x. What is different about this one? Product rule. Okay? So h prime of x is going to equal x squared times derivative of arctan of 5x. Okay, so over here my u is 5x, u prime is equal to 5. And from my equation, I know that I have u prime all over 1 plus u squared. U squared is 25x squared. Okay, so that now I did my first times derivative of the second plus derivative of the first, which is 2x arctan of 5x. So to clean this up, I would write 5x squared all over 1 plus 25x squared plus 2x arctan of 5x. Final answer.
You don't even have to make common denominator?
No. Nope.
Be awful, right? Well, not really.
It wouldn't be that bad, but we don't need to. Okay? So it feels weird to have an inverse tangent in our answer, but it is what it is. Okay. Let's look at example number 54. Y, and I have two more examples, this one and one more. So another bell's going to ring, but maybe we can, okay. So y equals natural log of t squared plus 4 minus 1/2 arctangent of t over 2. It is.
So we gotta,
So we don't have to do product rule or quotient rule, but we have chain rule. And over here for arctangent, what's my u? T over 2. And u prime is equal to 1/2. Okay, so y prime.
Which is already there. Or
No. You're thinking of like u substitution with integration.
Right.
Okay, this 1/2 stays when I take the derivative.
Did you just have 5 1? That makes sense.
Sure.
so we have to do the derivative ln.
Derivative of natural log of t squared plus 4, and that's going to be what?
2t all over t squared plus
2t all over t squared plus 4. Okay? Minus 1/2. Derivative of arctangent is u prime, which is 1/2, all over 1 plus u squared, which is going to be what?
t squared.
Okay? Here's where we need to find some common denominators. All right? So, let's go y prime equals 2t all over t squared plus 4. This stays. Minus 1/2. This 1/2 I can pull out front. Does that make sense? This 1/2.
So it'll be 1 over 4.
I can bring this out front to 1/2 times 1 over 1 plus t squared over 4.
So we just say 1 over 4.
Yes.
How can we just go off that?
Well, it'd be the same as if, what if I had a 2? Right? If I had 2 over 1 plus t squared over 4, that's the same as 2 times 1 over 1 plus t squared over 4. Right? That's why I can do that. So y prime equals 2t all over t squared plus 4 minus 1/4. Okay, now I'm going to do a little work in here. 1 over. And here I have 1 plus t squared over 4. My common denominator is going to be 4. So really, I can take this 1 and change it to 4 over 4.
So 4 plus t squared over 4.
Yes.
Do those
Okay.
cancel?
So now, if I 1 over this, I'm gonna not skip a whole bunch of steps here. So y prime equals 2t all over t squared plus 4 minus 1/4 times, if I have 1 over this fraction, I'm flipping the fraction. So now I have 4 all over 4 plus t squared,
It's the same thing.
which these 4's cancel.
And it's the same.
T squared plus 4, 4 plus t squared, they're the same thing.
So it's 2t minus 1 over.
We're not going to get one off that.
No, not a single person's going to show up from pre-cal.
Yeah, but
Okay.
you said it test.
Yeah, they had a test. And they wanted out. Their chapter 5 test. Yours is coming up.
We already had a chapter test. We just have
Yeah.
another one. Is the second one going to be a lot harder?
And not harder. It's going to have this on
It's
it.
just different.
So, yes. Okay. All right, are we good with that? All right, one more example.
Is it long?
No, but, well, it's, does anybody need to leave right now? You need to leave? I can email out the video if you want to fast forward to the end and watch it. Or give me at least 5 minutes.
Oh, yeah.
Okay. I want to take into account
These are long.
because it's related rates. Wait, what? Did she just say related rates? Yes, I did. And I want to look at those example problems. So this is example number 102. It's always good when it is in the hundreds.
Those are the worst.
Those usually are the worst.
You
Not
start doing
always.
102 and you start thinking like, you're up at 99, you're like, oh, I can still do this. And 100, nope, done. Can't do it.
Okay, so here is 102. Okay. It is a word problem. It's related rates. So it's on page 381 for anybody if you're at home and wanting to follow along.
Lexi probably is the duck out.
Yeah, Lexi, we know your book is out. Okay, so a patrol car is parked 50 feet from a long warehouse, and there is a figure. Okay, here's the figure for 102 down here on the bottom. All right, so from the drawing, I have a triangle like this, and this is theta, which already is kind of weird, right? And this is 50 feet, and this is x. Okay. The revolving light on top, so a patrol car is parked 50 feet from a long warehouse. The revolving light on top of the car turns at a rate of 30 revolutions per minute. So that's a rate right there. Something is turning 30 revolutions per minute. What is that? A rate is a derivative. D something,
Theta, D.
d theta dt. So revolutions per minute, that if you see the word revolution, that's theta. Okay? So d theta dt, and they're all going to be with respect to t because it's a rate. A rate is how fast is something changing. And a rate is a derivative, always down at the bottom is dt. So d theta dt equals 30 revolutions per minute. Okay. What makes this problem even better is that we need to convert this because we don't want it in revolutions per minute. We can deal with theta if it's in radians. 1 revolution equals how many radians? 2 pi. Okay? So I'm going to say 1 revolution is 2 pi, or d theta dt, then my revolutions cancel, and I get 60 pi radians per minute. Now I can deal with that for my theta. Okay, if I asked you, if I had a value here, and I asked you to find what theta was, what would you do? Here's my right angle.
I would do
SOHCAHTOA, but inverse.
Uber.
Right? Because tangent theta is equal to opposite over adjacent, or x over 50. So theta is inverse tangent of x over 50. Does that make sense? Okay? Now, if you remember back to related rates, I set up an equation with the variables. What am I asked to look for? How fast is the beam moving along the wall when the beam makes an angle of theta? So theta equals 45 degrees with the line perpendicular from the light to the wall. What I'm looking for, how fast is the beam moving along the wall? That is dx dt. Okay, so that's what I'm looking for. So in order to find a rate like this, this is the equation that I'm going to go with, and I need to take the derivative using implicit differentiation with respect to t, because all of my derivatives are with respect to t. So the left-hand side is going to be what? D theta dt. And now I have arctangent or inverse tangent of x over 50. My u is x over 50. U prime is 1/50th. And the equation for inverse tangent, the derivative is
U prime over 1 plus U squared.
u prime over 1 plus u squared. You're already memorizing it.
Yeah.
We've used this one a lot. So u prime is 1 over 50 all over 1 plus x over 50 squared is x squared all over 2,500.
What is the 2500?
50 squared. Is that it?
No.
No, because I just took the derivative of x and I need to do dx dt. If I don't put a dx dt, I'm not going to be able to solve for anything because that's what I'm looking for. Okay? So I can clean this up and I can say, okay, d theta dt is equal to 1 over 50 all over 2,500 plus x squared all over 2,500.
Bring the 150 out front.
dx dt.
Bring the 150 out front.
I can bring, well,
And then you
and
can-
again, because, I don't know, there's a bunch of different ways you can come
Or you
at
can
it. I
just-
can bring the 150 out front,
or you
and then I have
can-
one of that, but now I have a fraction over a fraction.
just cross it out.
So I can say d theta dt is equal to 1 over 50 times 2,500 all over 2,500 plus x squared dx dt. Right? I can do some simplification. 50 into 2,500, this is gone, this is 50. So I have d theta dt is equal to 50 over 2,500 plus x squared dx dt. Let's plug in what I know. D theta dt is equal to what?
30, 60,
60 pi. Equals 50 over 2,500 plus x. What x? How do I find x? I need to come back up here. They told me I'm finding the rate of change of x, dx dt, when theta equals 45. So I can plug in theta equals 45 to find my x value at that instant.
Maybe calculator probably, like, what's the way to get calculator?
So far we have not needed a calculator, and you do not need a calculator to find x.
Okay.
If this is 45 and this is a right triangle,
It's
it's 50,
Oh.
right? Because this has to be 45, that's isosceles, meaning this side is congruent to this side. So this is 50, these two legs have to be congruent. So x equals 45, 45, 90, yes. Yes, and also, yes. Okay? So I know that x is 50, so this is 2,500, or 50 squared, times dx dt. Okay? So now I have 60 pi equals 50 over 5,000 dx dt.
Take that 1 over 100.
I can make that 1 over 100. So 60 pi equals 1 over 100 dx dt. To get dx dt, I multiply by 100.
600 times.
It'd be 6,000 pi.
6,000.
What are my units?
Radians.
This is dx dt.
Oh, it's feet. So it's
Maybe 3%, maybe 3%.
Feet per minute. Okay? Because I was told that this length was in feet, so I know my linear values are going to be feet, and my time was minutes. So yes, it is feet per minute.
there's various things going down the quiz.
I will not put a related rates on the quiz, but you have.
They can't see.
Hmm? Oh, sorry. I do enter. Here's the final answer. It looks like I assigned one problem that is related rates
Oh,
for homework.
I was
There's another one on here. I don't know that I did not assign that. I'm pretty sure I assigned number 99. I believe that I took. Hmm?
It's not 100. So.
No, I also assigned one on the 109 was one I used to assign. I got rid of that. So, yeah. Okay, that is it.
Bye, guys.
Bye, guys.
I looked